Okay, so I got the SWR down to about 1.07. It's kind of walking around. I had it at 1.06. And I did that just by bumping the inductor. I got the capacitor kind of in the ballpark range. And then I started just bumping the inductor, the roller inductor, by turning on and off the motor for that. Like so. Let's see if I can get that any closer. 1.08, 1.07, 1 point I had 1.06. Yeah, see I'm going the other way. So reverse the polarity, bump that the other way, 1.06. That's pretty good. Knock the 1.08 again. Splitting hairs. 0.09. But that's more than acceptable. 0.07. So there you have it. It seems to be a success. There's the position of the capacitor or the condenser in this L network. And this is the antenna for the sloper. Goes up, goes over. And there's the battery. So pretty happy with this for a prototype. Here it is drifting up to 1.08 again. Should be able to get that perfect. But there we go. So the idea of that is to be able to run some control cables out here. I'm assuming I'll power it from in the house and put the reverser relays in the house instead of putting all that electronics out here subject to the weather. Bad enough the motors themselves are open frame on the back side a little bit. So I'll have to keep those dry. What I might do if this works is put the whole thing in a sealed box, in a big Tupperware box that has a lid and is sealed. And I could either set it on the ground in a corner, up on the blocks, or screw it to the fence. It won't have to have any openings whatsoever. I could even put a porcelain insulator for the antenna lead and the ground leads coming in, and control all of this remotely. I bring just 4 wires, 2 for each motor. I should have measured the current. I don't know how much current these motors draw, whether or not it gets a lot of voltage drop if I run a piece of Cat 5 out here, or if I find some 4-conductor wire that's a little thicker than Cat 5, that will reduce the voltage drop. And then in the house, I'll make a control box with a reverser. And boy, it's going to be a challenge to control this with a microcontroller, measuring SWR and walking the capacitor around and the inductor. But that'll be fun. It'll be a good challenge for this winter or even the summer. And the nice thing about it, I can do all that in the house, the comfort of my ham shack there, with a computer and a nice chair, and just play with code. It sure beats having to sit out here on a chair in the rocks and tweak on the knobs here with the VNA here. But yeah, I'm happy with that. I got a good match, and I did it all without touching anything. One thing about the gear motors, there's no clutch, so I can't actually adjust it. I took off the turns counter off the inductor, and I can't turn that because it's I've got a gear driven motor on the back end of it, on that shaft on the coupler, so it'll bind. So the whole idea is you're going to have to do it electronically, electromechanically. So that's kind of the idea here. I still have to work on the limit switches for the inductor. I have to figure that out yet. If I do put limit switches here, I'll need more than 4 wires. I'll need at least 3 more here. If I put a micro switch here, or a micro switch there, or I could do some current sensing in the house. When that hits full lock, the current's going to go up. So I don't know which is going to be easier, probably to monitor the current through a resistor of some sorts than to have 2 micro switches, a common, and 2 wires there. Maybe the micro switches will do okay. So that'll be 4, 5, 6, 7. So it'll be 7 wires. Yeah, Cat 5 is 8, so that might work. Anyway, there you have it. We'll see you later.